looking at where two different equations will cross. So every problem has two equations in it. That's called a system. So instead of just solve, it says solve a system. There's two methods, well there's three. The first way to solve a system is to look at the graph and see where they cross. The second way to solve a system is elimination, which we did not do yesterday. And the third way is substitution, and that is the example I did yesterday with substitution. I did want to just play elimination with you. We did it like a month ago, I'd say. So we got y equals x squared minus 1, which I can picture that. I can picture that parabola. And negative y equals 2x squared plus 1. Now, I really just want to see the picture. I want to make sure that you're connecting your math to the visual. I think every time we can reinforce our equations with a picture is a good idea. So I'm going to look at this one before I even do the problem. So the first one is x squared minus 1. There she is. It's our parent quadratic, just shifted down 1 unit. And the next one, I can't put this into Desmos just like this. You can't enter into Desmos unless y is alone. The negative sign is kind of messing everything up. So before I can actually put this in Desmos, I'm going to divide both sides by negative 1. So I'm really going to type in negative 2x squared minus 1. Okay, so this is a visual there of what we're solving right now. We're looking for this point where the positive parabola just touches the negative parabola in one place. The intersection. All right, so if you don't want to go through the hassle of graphing, you can always do elimination or substitution. For elimination, we do a big plus sign. We add down. For elimination to work, you have to have opposite variables, either opposite y or opposite x. So this problem is really set up for you because it has the positive y and the negative y. When I add down, these cancel to be 0. 1x squared as a 2x squared is 3x squared. And negative 1 plus 1 is also 0. So I know sometimes we get to 0 in our math and we worry that we've done something wrong. But this is it. We do have a 0 here. I'm going to solve by square rooting, so we better divide by 3 first. 0 divided by 3 is 0. Not going to be fine. And now I have 0 equals x squared. And this reminds me of the square root method. Square root both sides. And I get plus and minus 0 equals x. And positive and negative 0 is the same thing. So x is 0. Bless you. Unfortunately, sometimes we stop there. And really, we need a whole point. A system. All chapter we've been finding x. Okay, so it's reasonable to stop here, but today we're trying to find x and y. We're trying to find an ordered pair. So don't stop, find y.
Wait. Oh, you combine them?
I added down, yeah.
Oh.
And so I'm going to take this 0 and I'm going to put it into the top equation, and that's going to lead me to the y value. Yeah, y is 0 squared minus 1. Y is negative 1. So my answer is a point. It's a full ordered pair. 0, negative 1. And that's what the graph told me. That's what the graph told me when I pulled up the Desmos. substitution method, we could do elimination, but you're supposed to really be able to do graphing, substitution, and elimination. So yesterday we did this, and they're set up nicely for you. What we're going to do is we're going to look at this bottom equation is telling us what y is. Y is the same as negative x squared plus 14. So I'm going to take this y and I'm going to take it out. And I'm going to put a little replacement in, a substitute in. And I have negative x squared plus 14 equals 0.5x squared minus 10. Did anybody go the other way? Rowan, did you do the first step?
No.
Because some people have it, and I can't figure out the majority. Some people have this one on the left side and this expression on the right. It doesn't change the answer. It doesn't matter at all. We're pretty much just setting them equal to each other.
And then what?
Now we're going to combine my terms and collect it all on one side and solve it. There's so many right ways from here. I keep doing it one way and students are doing it another way. So I'm going to ask you guys, should I add x squared to both sides? Or should I subtract 0.5x from both sides? Which way are you doing? I add. That's because
Negative.
they don't want me to do that. I'm going to plus x squared. I never like a negative squared term. I'm going to plus x squared to the other side.
That's what mine is.
So 14 equals 1.5x squared. That's 1 plus 0.5 is 0.5 minus 10. And then I have a quadratic here. Maybe I want to make it equal 0. Maybe. I don't have to. There's more than one right way. And this is 0 equals 1.5x squared minus 24. Now I can use the quadratic formula to solve it. But actually, what I see here is A is 1.5, B is 0, C is negative 24. Anytime B is 0, you could just use the square root method like we did in number 1. Yeah.
How do you do that?
We can use square rooting. Or we can use the quad formula. And it's 100% full credit for either one. Sorry.
Is that a cellular device? Like, I will tear these. I thought you were about to say something. Bro, shut up. That was the same phone, bro. Leave your bag back. Wasn't Ladies, I better see you all out. I'm not gonna go.
What? To do the square rooting method, I would add 24 over here. And you can square root sooner. If you get to the right answer, it's totally fine. There's several correct ways to
Wait,
finish
so
this.
you could have just added 10 over the 14.
You could have, yes. And I get 16 equals x squared. Hit the square roots. And we have plus and minus 4 equals x. Yeah, so Rome said if I would have just added 10, this must have two solutions since we have two x values.
Wait, why would it be plus or minus -4?
Well, because 4 squared is 16, and negative 4 squared is 16.
Oh.
So I'm going to take this 4 and put it in here to find y. And I have the answer at 4, -2. I'm going to do it again with the -4. I'm going to put it in the same spot.
Who did that?
It sounds like it. It sounds like it worked fun. Or maybe it was medical thing.
What?
Medical thing though. Maybe there was a break or a catapult. Where did it go? Oh, it's right here. Whoever has a blue pen. You do?
No. Can you
Oh, it's
can you
Israel.
read the homework? Mommy's getting mad at me because I'm guilty by
No,
association.
I can make it. Oh,
Because you're talking about the homework from this week. Yeah, our grade assignments once a week. So now, if you want to stop by after school, I can jump into that. But because I'm covering right now during my planning period, grading's going to take a little bit longer. 2 answers. Let's take a look at these 2 answers.
What was the song you were singing?
Alright, here's our 2 answers. I like to check it, get a visual. We're at 4, -2. -4, -2 right here. Any questions? So, what did yours like better? Elimination or substitution?
Elimination.
Which one did you like better, doing number 1 where you add down, or number 2 where you plug in? Who likes just looking at Desmos best? Me, I do. Yeah. Yeah.
You.
Let's look at the assignment. What I will do on your test, and I'm putting this out here right now, is I'm going to give you a question just like numbers 1 through 4.
I just realized.
And this is the equivalent of using Desmos. So what I'm going to do is I'm going to give you a picture on your test and ask you what the answer is. Where you don't have to make the graph yourself, where you're just proving that you understand the solution to a system is an intersection point. So number 1 online yesterday was no solution. Number 2 was -4, 1. Number 3 was maybe the most difficult, where they overlap here in the middle. And then number 4 was tricky too because this goes by choose. And you have to look in the middle. So you will have a test question where you don't have to draw it by hand. She's going to give you a picture and say solve. Some people are doing all of the math, even though the picture is given. Don't waste your time doing the math if they give you the picture.
What if I got for that one? What if I got 6 and -6?
Then it's wrong.
But look, here's what I did.
It doesn't matter if you did it wrong. This is the only answer. I mean, it's proven.
Well, what about like what? Okay, so you see the 1.5. What if you factor? You factor a times c and then 1 times c. A times c.
It has to add to 0.
It does. 1.5 times -24 is -36. 6 times -6 is -36. 6 plus -6 is
it's 6 times negative. Yeah, he's right.
Okay, so you're writing -6 in the middle,
Yeah,
like this.
yeah. Oh, I forgot you gotta do that. Oh my god. I thought you just put it in parentheses. Wait, no, it's +6 in my mistake.
Okay. So, what do you factor out of the first one?
1.5x.
What are your parentheses when you get this? When you finish it, what do you do?
Oh, what I did is I just put x +6 and x -6.
Okay, but remember, Kenny, when you do that, you should be able to check it by foiling.
How do you FOIL? Oh no, I just subtracted 6.
Yeah, but if this doesn't yield the same problem you started with, you know you don't have answers.
Oh, okay, well, okay, so you do it like that. Keep factoring real quick.
Okay, go ahead. What's the GCF between these two?
1.5.
Okay.
1.5x,
Okay.
and then that'll be x, and that'll be 4. And then after the 4, oh my, wait, it is -4.
No.
Thank you for your input. Wait, no, wait, what? Wait, yes. Wait. No, I can't give up. Giving up is for people who give up. Exactly, and then it worked. So why'd you say I was wrong? When secretly I was never wrong. I'm never wrong. Ever.
Yeah, chill. Chill.
That's OD.
Chill.
Wait, but why would it be -4?
Because this was a positive 6, because you're right, it's negative positive. You're pulling a positive 6 out of these two. 1.5x plus 6.
Well, shouldn't it be -4 and 4?
Yeah, I got it. When I put this equals 0, I get -5.
Oh, I forgot about that. Yeah.
So good job, you factored with decimal.
Thank you.
That's a really good job. That being said, you could have also square rooted.
I searched it up. It's my knowledge.
Factored with the decimal. Alright, I want to look at this.
Wait, what day is it today?
Wednesday, 6.
Oh.
I want to look at the 3 substitution problems in your assignment yesterday. Again, hopefully you did it on paper. You didn't just click answers and guess. Unlimited amount of time. Yes?
Are we supposed to do it on paper?
I think somebody's on right now.
Do we have to show our work?
You don't.
I have my work.
Right, because you're figuring it out. But there's a lot of students who are just checking unlimited times. You don't get unlimited checks on the test, you guys. So if you're doing that, your grade's not going to be very good. Does anybody have a question about number 19?
No.
Yeah. Sure do. Alright, does anybody have a question about any of the 3 math substitution problems in the assignment yesterday?
No.
So, moving forward, if you're submitting answers online, you should come in, even if you only did 2 steps on paper and you got stuck, come in with those 2 steps on paper and say yes, I couldn't do number 5. And then we can look at it, and I can help you finish it, okay? So since we've been answering online, there's been a problem, no one's asking any questions. And I don't think it's because you haven't figured out. So ask a question. This was number 5 yesterday. Online.
Put your hand down.
And here's number 6 yesterday.
Wait, is that today's homework?
No. Here's 7 yesterday.
I can't.
So no, yes. No. Yep. Today's your last day of your material. But I've been doing at least one of these in every class. Because the student says, yes, will you do 5? Wait, will you do 6? Will you do 7? Does anybody want to ask?
Wait, what?
Page 275, go there. Actually, forget about that. Go to page 278. Alright, so what we just did was a system of equations. This here is a system of inequalities. What's the difference between an inequality and an equation?
They're not equal.
The alligator mouth. Also, they're not equal. Sometimes they are.
Oh,
A system of inequalities is a set of two more inequalities in the same variables. Here's an example. So just like yesterday's work, but instead of equal signs, we have the alligator mouth. The only way we're solving these this year is through graphing. So we're going to graph both equations and we're going to shade them in because inequalities require shading. And then wherever the shading overlaps is the solution to the system. With inequalities, there are several solutions to systems, almost infinite if we really wanted to get down to it. So today's objective is to create these graphs where you're coloring in, and looking at where the coloring overlaps. Yeah, any point in here is the answer to this one. I think that was actually. All right, here is first off, here are the page numbers for this section. It's 275 to 284. I recommend you read it and look at the examples. I have read it and I've summarized the important topics here and here. So here is a summary of the section. You don't have to write this summary down word for word, but these two things are going to really help you do the problem.
Oh.
Colin, what would you predict goes in the first blank space in this green statement? I know. Can you even read it? Maybe I could zoom in. Maybe I zoom in and take this one little statement at a time. Can you read it now?
Yes.
This is our goal today. We're going to graph both inequalities. The area we're shading blank shows solutions. What word can we put in there? Colin? Overlaps. You got it. Here's some kind of fortune teller. Alright, there's two important qualities as you go to make these graphs. The first one is if the symbol is y less than or y greater than, you connect points with a blank line. Can anyone figure out what that blank space is?
Yes.
Jacob, you know? If I have this symbol or this symbol, what type of line is it? Yeah.
Inequality.
No. Dash line. Dash line. So these graphs today start to require dash lines. If this symbol has the equal to sign under it, you're going to do a solid line like we have all year. All year we've been graphing with solid lines. But if it's this symbol or this symbol, you get to do a dash line. Dash line. And the second quality has to do with shading. Hope I'm not moving too quickly. Whoa.
I'm not done. Take 3 deep breaths. For real, yeah.
Okay. Alright, if the symbol is y greater than or y greater than or equal to, you're going to put your pencil on your y-intercept and you're going to shade up. Because greater is up. Numbers get greater going upward. So for these, you shade up. But if your symbol is y is less than or equal to, you put your pencil on the y-intercept and you shade lower. You shade below it because less than is lower. And then we're going to do one example and I'm done. Oh my gosh, the answers are there.
Wait.
Yesterday I zoomed through that graph, and but I did try to remind you about slope, rise over run, y-intercept.
Giant.
So here's the example I'm going to do. I'm going to grab this inequality and this inequality on the same coordinate plane. I don't want to get ahead of you if you're writing your tips down. In fact, I can still zoom in if I'm zoomed out too quickly.
Oh my. Watch my damn. Language. I said what? I said damn. Oh my.
Okay, I'm going to highlight in blue. Y is less than x minus 8. How do I graph that? Yeah, but like literally, what's your first step in making the graph? You will leave your phone here, okay? The y-intercept is -8. Yeah, landed it at -8. J to A. What's the next move in graphing a line? You see the blue highlight? I can make it green, ready? You see the green highlight? I've already put it down at -8. What would I do next?
Wait, what? Never mind.
Actually, this top one in green is not square. I'm gonna do slow, rise over run. And I'm gonna go up one over one, up one over one. I got a straight line. Straight lines are quicker and easier than parabolas. So I'm happy I got a straight line to do.
Yeah.
And I'm gonna connect this with a dash dash instead of a solid. I messed up my straight line. Dash dash. Through the coordinate plane. I'm gonna go Leo.
Oh, Leo.
Leo.
Yeah.
How do I finish up my dash line?
Shading the bottom area.
Yeah, that's what
Good job, Gramps.
you're on it. You just knows it all. Alright, this symbol means shade down from whatever that y-intercept was. It says it right here. Shade down. So I'm gonna put my pencil on the y-intercept and then go lower. Color and lower. Now, I'm gonna fill in that whole side. So I start with just below it, but then whatever that looks like from there, I fill in everything on that side of the line. So this shading, all of the points in this shading, if I plug it into that green highlighted inequality, it will come out trim. I don't know, how's that work?
Wait, how do you find the slope?
It's the number for x.
Oh, so on. Wait, in a quadratic formula, how would you the parabola?
Probably.
How would that one be?
Yeah, so let's do the parabola next. Oh my gosh.
Go.
I think somebody said yesterday they don't remember how to graph a parabola. So we better go through it. So now I'm doing the parabola. The parabola, I start with negative b over 2a. And I got the axis of symmetry, the positive one. Oh my gosh, I'm gonna get confused now. Right.
How do you know it's one?
Let's see if it's organized.
Yeah, it's true.
I did negative b over 2a and I got 1. What's your next step?
You find, you plug in x in the equation.
Yes. Plug in x equals 1 to find the vertex. So it's going to be y equals 1 squared minus 2 times 1 minus 8.
No idea.
Negative 9. So now I have a vertex. I have 1, negative 9. Right there. And then I also have an intercept at negative 8. And I also know there's no stretch or shrink, so I just open up 1 over 2 up 4. Boom.
Wait, why would you go like that? Wait, what? Wait, I thought it was a slope of 1.
Okay. So.
Why did you go up by 100?
Yeah.
Wait,
So non-linear equations do not have slopes.
so why would
They
you?
don't have a rate of change. This has a slope because x is not squared. The relationship stays constant for a straight line to infinity.
So you would go up by 3?
The relationship in x squared would be, well, from the vertex, 1 squared is 1, so I go over 1 up 1. From the vertex, 2 squared is 4, so I go over 2 up 4. From the vertex, 3 squared is 9, so I can go over 3 up 9. A non-linear equation does not have a consistent slope. It changes. This one gets steeper as it goes through. Yeah.
Oh.
Yeah, just for the rest. Yeah, until you're done school,
Thank you.
know how to graph a quadratic.
I understand.
Yeah. Is it? It's not on the reference sheet. It actually, in 6th period, we looked it up. The quadratic formula is not on the SAT reference sheet. So you do have to memorize that. Okay. Who else has a question about how I got this green parabola? It's looking kind of crazy. There's a lot going on there.
Because of the equation.
This says y is greater. So I'm going to put my pencil on this y-intercept and I'm going to shade up. It just happens to be inside the parabola. Sometimes it's outside. So I'm shading up and it's inside the parabola. There it is. So the answers, all of the solutions are shaded green because that's overlaps. So shaded green is solution. Shaded lime green is solutions right here. This was shaded both blue and yellow. That's the overlap.
Wait, why would you shade in the inside of the parabola?
Because this says y values are greater. So I'm going to this parabola, the boundary line, and I'm shading the y values that are higher.
So what if it was less? You would change the outside?
I would go here, yeah, the outside would be shaded. And you won't figure that out until you really try it yourself. You've really got to get into this and practice it yourself. There's a lot of scenarios with shading here.
What if it had the little line under it?
Then I wouldn't have a dashed boundary line. This would be solid like it always has been.
Oh, okay.
Alright, your assignment's online again. The first four look a little different than what I just did. So get it pulled up so I can do number 1 with